Here's your homework help for tonight, and you only have to do number 1. You can try number 2, that would be a bonus, but if you hang in there and complete number 1, and then check your answers with the video, that would be great. So I want to give you the opportunity now to pause the video and try to work it out on your own. And after you're done that, you can check the answers with the video. So if you've already done that, hopefully you've taken the chance to try it on your own, and I'm going to explain how you get the answers. So if we look at these 3 shapes, we're going to consider each pattern. And what we're going to do is we're going to make a table to show the relationship between the number of trapezoids. Here we have 1, we have 2 over here, and then 3 over there. And the perimeter of each of these shapes. So you should see a pattern. And if you look at the bases of the trapezoid, top base and the bottom base, you'll see that there is a pair of a 3 and a 6. When we add 3 and 6 together, what number do we get? That's right, we get 9. So when you add those together, you're going to get 9. So in this one, we have 1 trapezoid, we have 1 set of 9. We also need to account for the sides, and we have a 3 on one side, and we also have a 3 on the other side. So this 3 with this 3, 3 plus 3 would be 6. So we have a set of 9, 9 times 1 trapezoid, plus the 6 on the outside. If we were to add all the sides together, it should be the same. It should be equal to 15. So we could do 9 times 1 trapezoid plus the 6 on the outside, and we get 15. Or if we added them all together, we should get the same number. 2 trapezoids. We have a set of 9 over here. We also have a set of 9 right here. So our bases, when we add them together, is equal to 9. So because we have 2 trapezoids, we have 2 sets of bases. So we're going to do 9 times 2, and if I added all these together, I should get 18, or 9 times 2. And then we have to account for the sides again, so we're going to add 6 to that 18, and I should get 24. So the perimeter in the second shape is 24. The third shape, we have 3 sets of 9. We have 3 sets of bases, and when we add those bases together for each trapezoid, we have 3 sets of 9. So we can multiply 9 times 3, and we get 27. And then we're going to add the sides on the outside, plus 6, and that would be equal to 33. So if we added all of the sides, we should get the same number. It should be equal to 33. And our perimeter for the first one, let's just go over that again. There's 1 set of 9, so we do 9 times 1 plus 6 is equal to 15. If I added them all together and did it the long way, we would get 15. For the second shape, I have another pattern. We have 2 sets of 9, so we're going to do 9 times 2, which is 18, plus the 6 on the outside is equal to 24. For the third shape, I have 3 sets of 9, which is 27, plus the 6 on the outside is equal to 33. So my table, we're going to get the number of trapezoids on the top, and then we're going to put the perimeter on the bottom. I'm going to make ordered pairs from that table. We're going to use the number of trapezoids as my first term and my perimeter as my second term. And if this was an ordered pair, usually when we see ordered pairs, if we think of the coordinate system, your number of trapezoids are your independent variables. We could have any number of trapezoids, but the perimeter depends on how many trapezoids we have. So we call that the dependent variable. So we call the number of trapezoids the independent, or the x values, and we call the perimeter the dependent values, or the y. So you see 1 comma 15 is my first order pair, 2 comma 24, 3 comma 33, and those are my set of ordered pairs. The next part here, we have to make a graph. So we take these ordered pairs and we do what we usually do with the coordinate system. We go over first, and then we go up. So you'll see that we label our graph with our x values, or the number of trapezoids, going horizontally or across the x-axis. And then the y values are the perimeter, so that's going to run vertically. If we have 1 trapezoid, we have a perimeter of 15. If we have 2 trapezoids, we have a perimeter of 24. If we have 3 trapezoids, we have a perimeter of 33. So you'll see the dots are placed in the right coordinates there. The last part is we're going to write this in our own words, and then we're going to write an equation. So your word should look similar to what we have here. The perimeter is 6 more than 9 times the number of trapezoids. Or you could have put, to find the perimeter, you multiply the number of trapezoids by 9 and add 6, something similar to what we have written here. The equation, write an equation for the relationship, we could use P for perimeter is equal to 9 times n plus 6. That n would represent the number of trapezoids. I want you to think about how we would rewrite this, or how we could rewrite this if we were dealing with x and y values, and how we wrote it in class. Instead of writing p, what value or what variable could I use? Instead of writing n, what variable could I use? And we'll talk about that in class tomorrow. For number 2, you can try your best, and I want to see if you guys can get it on your own. So do me a favor, just try. And I'll kind of get you started with the table so that you can at least shoot for the pattern. Your surface area, you have 1 plus 1 plus 1 plus 1 plus 1 plus the 1 over here and the 1 over there, which isn't showing, but you'll know that there's 6 faces for this cube. So if we did 1 times 1, this would be 1, have an area of 1, this side would have an area of 1, this side would have an area of 1, and then the faces that aren't showing would each have an area of 1. So those 1s represent the area of the faces. So if there's 1 cube, we have a surface area of 6. If there's 2 cubes, we have 1, 2, 3, 4, 5. Then you have to remember there's 6, 7, and then 8, 9, 10 faces, and you can't see some of them. Again, this is